Okay, so here is example 2 from in class, and I left you with this drawing, and I also left you with that we're going to do the outer function minus the inner function. So let me draw the two-dimensional drawing again. We had y equals 2, and then we also had our 6 minus x squared, which is an upside-down parabola. We have this shaded region in between, and then we can set the two equations equal to each other to solve for the points of intersection here. And then in class, we talked about we're going to take the area of the outer function. So we have the outside function, and we have the inside function. So right here, we know our circle formula. I plugged in the radius, and then I'm going to compute, and I'll get that. Okay, so I left you in class that we're going to have the boundary from -2 to 2, and we're going to take our outer and we're going to subtract our inner. And this is with respect to x. Now, since this is an even function, I am going to do that trick that I showed you in the last video, and I'm going to change my boundaries here, okay? Pull the pi to the outside. Now, since this is an even function, I'm going to multiply this by 2. How can I do that? If you look at the graph, the distance between -2 and 2, if you look at the shaded area in here, that's the exact same thing as twice the area from 0 to 2. I love having 0 in my lower boundary there because it makes our work so much easier. I go ahead and I combine my like terms. I went ahead and integrated there. I did do that a bit quickly. I skipped a couple steps, so let me know if you didn't understand that. And now I'm going to plug in my boundaries. And I'll have that. And I will keep doing the work. And we'll keep crunching these numbers. Okay, so there you go. That was example 2 to the section 5.2 notes.